So good morning again, class. This module 8 is retaining walls. Okay, what are the different types of retaining walls? What is a retaining walls? Okay, so last prelim, pero may overview na tayo what is a retaining walls and ano yung mga ginagamit sa mga parameters na ginagamit sa pag-design of retaining walls. Okay. So what is a retaining wall? A retaining walls are rigid wall structures that supporting the soil laterally. So it helps that it can maintain the surface of the ground at different elevations on either side of the structure. Okay, so if there is no retaining wall support, the soil at a higher elevation will tend to move down till it acquires its natural stable configuration. Okay, so for example, we have this mat foundation. Okay, I think malaki yung foundation natin. This project. Okay, so this is a foundation. A foundation ito. Then, syempre, dun sa foundation site, sa site natin, kailangan natin magkaroon ng excavation, di ba? Di naman dapat lahat is excavate natin yan. So, ito yung retaining wall. Yan yung area na yan. Ito. Okay. Ito. Yan yung mga retaining walls. This one. Yan. Yan yung mga retaining walls natin siya. Dito rin also, we have retaining walls. This one. Ito. Yeah. So yung retaining walls is basically to help and maintain the surface, okay, para hindi siya mag-slide, okay, yung soil hindi mag-slide kasi may gagawa tayo dito sa ilalim. Okay, so for excavation, so for protection to hindi mag-slide or topple over yung mga soil dito sa taas. Okay, so what are the different types of retaining walls? Okay. Number one, we have this gravity retaining wall. Okay. So gravity retaining wall assures its stability by its own weight. So the walls are majorly designed to eliminate the overturning effect of the lateral earth pressure and do not induce tensile stress within the section. So gravity retaining walls are suitable for the low height and are not economical for large heights. So it can be made from stone, bricks, mass concrete, and precast concrete blocks. Okay. So this gravity retaining wall, so by the word itself, gravity, okay, so it is basically parang nakadepende lang siya dun sa total weight of the retaining wall. So para siyang dams, if you recall your fluid dynamics. If nakaabot ba kayo sa analysis of dams, no? Hello? Nakaabot naman kayo ng analysis of dams?
Yes po.
Okay. So just like yung analysis of dams, di ba sa analysis of dams, we have this factor of safety against sliding and factor of safety against overturning. Okay, so if you recall, we have this mu ry over rx, factor of safety against sliding, and factor of safety against overturning is Rm over Om. Okay, riding moment over overturning moment, di ba? Okay. So yung riding moment is due to that lateral forces, okay? And the overturning moment is yung due to the gravity. Okay, mag-overturn yung buong retaining wall. Okay, then ang mangyayari is yung soil dito, kunyari may tao dito nagagawa, okay, mag-overturn yung mga soil and the whole structure will collapse. Okay, so this is not economical for a very large heights. Okay, for our retaining walls. Okay, for our retaining walls, take note. So for our retaining walls, this is not economical for a very large heights of excavation because it is much expensive. Okay, so kaya hindi ito ginagamit for let's say mga 4-story yung ilalim ng excavation, mga ganun. So napakataas nun. Then imagine kung ilang volume of concrete. So for example, you have this 1,000 square meter of floor area na gagamitin mo. Then ito yung excavation, then 4 meters below. Imagine kung gaano karami yung mass concrete na yan. Okay? So next is we have this cantilever retaining wall. So reinforced concrete cantilever types of retaining wall are recommended for heights of up to 7 meters. So this type of wall has a vertical stem monolithic with a base. Okay, this is what we call the stem. Okay, a slender section can be used in this retaining wall for a tensile stress within the stem, and the base is resisted by steel reinforcement. So in case of the slope of the wall exposed in a small backward batter of about 1 is to 50 is provided in order to compensate for any forward tilting of the wall as shown in the figure. So this cantilever retaining wall, okay, bakit siya tinawag na cantilever? Okay, bakit siya tinawag na cantilever is because this retaining wall has a stem. Okay, we have this stem. Okay, within the soil. Okay, so kung may force dyan, nagkakaroon siya ng parang ito yung fix. Okay, this one is yung cantilever. Okay, so magkakaroon ng fix dito sa may toe. This one yung toe. So this one cantilever, then tutulak ito yung lateral force. Okay, magkakaroon ng ganito. Okay, ayan, tumulak siya. So that is the cantilever retaining wall. So meron pang ibang style ng cantilever retaining wall, yung ganito na mga style. Dalawa silang may yung stem. May stem sa kabila, may stem din sa kabila. Yan. Merong ganyang style ng cantilever retaining walls. Okay? Next is the counter fort retaining wall. So yung counter fort retaining walls are used for height more than 6 meters. So each stem is provided to a slab opening, slab spanning between the counter fort supports. The distance between the support is about 2/3 H but should not be less than 2.5 meters. So this is a special type of cantilever retaining wall, whereas meron kang counter fort. Ito, this one. Counter fort ang tawag dito. Okay, and just like dun sa retaining wall, meron kang stem. Then this one is yung heel slab, and this one is yung toe slab. Ito yung maliit doon na area. Okay, again, kung heel slab, kung saan yung na highest for example this one. Yan. Okay, kung nandito yung soil mo, okay, so syempre dito magta-topple over yan. So ito yung heels. Okay, yung heels, and ito yung okay, sorry, it should be this one. Ito yung toe, sorry, this one is your toe, and this one is your heel. Okay, so paano ba kayo mag heels? Magtingkayat. Pag magtingkayat tayo, yung nasa ilalim natin is yung toe, then yung heel is yung aangat. Okay, so that is this one. Okay, then itong counter fort will act as a shear key. If you know what is a shear key, okay, shear key guys is ginagamit ito dun sa kaya siya tinawag na shear key. For example, ito. Example, this is precast. Okay, so precast, parang Lego. Di ba meron siyang insertion dito? Okay, so parang ito yung isang surface, ito yung isang material, then ito yung isa. Okay. Kaya may shear key yan, kapag tumulak ka dito, hindi mo agad yan matatanggal. Okay, dahil meron silang shear key. This one is yung shear key. Okay. So this counter fort retaining walls, ito yung counterfort na to. This counterfort will act as a shear key. Okay, this will gives additional strength on the shear of the retaining wall. A shear strength of the retaining walls. Okay, that is a counterfort retaining wall. Okay, next one is we have this buttress retaining wall. Okay, a buttress wall is a form of a counterfort wall, whereas nasa harap yung mga counterfort. Okay, these types of retaining walls are built on the face of the wall and not within the backfill. So buttress walls are not too popular because of their buttress shape exposed outside, which consumes the space and spoils the appearance. Okay, so ito nakikita to sa mga yung medieval period ba yun? Okay, yung mga sinaunang style ng mga walls. Okay, we have these buttress walls exposed, mga counterfort wall exposed siya dun sa face of the wall, hindi siya dun sa loob ng backfill. Okay, so this is the buttress walls or buttress retaining walls. Next one, we have the retaining wall. Okay, the crib retaining wall is shown in the figure, is given by this one. The crib walls consist of a series of boxes made from timber, precast concrete, or steel members, which are filled with granular soils. So it acts as a gravity wall with an advantage of a quick erection. Yung crib retaining wall is para siyang geogrids. Para siyang mga grids or this one, mga grids yan. Then meron niyang slots, yan ang mga slots. Yung slots na yon, pwede mong lagyan ng soils, granular soils, or any other filling material. And this will act as a gravity wall. So basically nakadepende lang yung strength nito dun sa total weight of this crib retaining walls. So meron siyang slots. Ito. Lalagyan mo siya ng soils. Okay, yan. Mga slots na. Bawat grids may slots ng soil. Then lalagyan mo lang siya. Okay, so I think meron ito dito sa Philippines, may mga gantong retaining walls, crib retaining walls. Okay. Then next is the gabion retaining walls. Ito, this is very popular, especially dun sa mga province dito sa Philippines. Okay. Yung gabion retaining wall. These retaining walls are constructed from a rectangular metal cages or baskets. Yan, metal cages or baskets. A gabion wall is made from a square grid of steel fabric, generally 5 mm in diameter, and spaced at 75 mm apart or 3 inches apart. So the gabion basket are usually 2 meters long and a 1 meter cross section. Okay, so 2 meters long. Ito, basically, this is 2 meters, and we have this 1 meter cross section. Okay. At the time of making, the stone-filled baskets are secured together with a steel wire of 2.5 millimeters diameter, or the base width of the gabion wall is about 0.5 each, typically wall shown in the figure. Okay, so a good-looking face can be provided by slightly stepping back para siyang magkakaroon ng stepping stone, okay, stepping dun sa gabion walls mo on each succeeding layer. So this is basically yung ginagamit sa mga province. Kung mapapansin nyo, kung may nakita na kayo doon sa mga province nyo, meron niya mga steel matting na tinatawag. Yan, this one. Then, for example, this is yung box. Okay. And steel matting yan for approximately 2.5 millimeters. Then, lalagyan niya ng stone. Ilalagyan niya ng mga bato-bato. Okay, then syempre bago ang paglalagay dito class is ire-ready muna yung mga steel yung steel cube na yan, yung steel matting na yan. Then tsaka lalagyan ng mga bato. Okay, so isa-isa mo siyang lalagyan step by step. So unahin yung ilalim, Medyo taas, ito hanggang dito. Okay? And additionally, kung mapapansin nyo class, this one, so this is some other types of soil stability, ito. Parang sapot na to, pero that is a geonets. Okay, this is a geonets or to help stabilizing the soil. So last is, di ba, may isa pa. So last, this one is a sheet pile retaining wall. So yung sheet pile retaining walls is most popular in high-rise buildings. Okay, sa mga high-rise, mid-rise buildings ng retaining walls. Okay, sheet pile retaining wall are constructed from a series of interlocking piles individually driven into the foundation soil. So nowadays, modern sheet piles are constructed from steel, timber, or precast concrete sections are also used. Sometimes a cantilever sheet pile walls are held in the ground by the active and passive pressure that act on its lower part. Okay, so napakadali kasing ilagay nito eh. So, kunwari may backhoe ka, yung backhoe lang yung magdi-driven na itong mga sheet piles na to. Case then, manufactured naman yung steel na yan. So, ito, dinudugtong lang dito. Yan. Okay, this one. Then also ito. So, kung mapupunta man kayo sa construction site, okay, sa construction site, as QA, QC for structural. Okay, so mapapansin nyo na laging may mga sheet pile na ginagamit for retaining walls. Okay, this one, sheet piles. So basically the same lang din siya dun sa mga pinasolve natin sa lateral earth pressure. So meron kang assuming this is your retaining wall. Okay, and meron ka ditong passive and active side. Okay, so ilan yung i-driven mo na H, di ba? If you recall your example problems. And H, meron kang lateral force dito. Given yung parameters of what is the P, okay, then the unit weight. Okay, so basically you can solve this sheet pile retaining wall. So kung nakasolve mo yung yung forces and yung overturning moment. Overturning moment. Okay, ang pag-solve lang niyan class, na-solve mo yung overturning moment. Okay, basically ganito na siya. Para siyang nagde-design ng slab. Okay, meron is overturning moment. Okay, so additional using load combo kung gusto mo for using LRFD or using a service load if you want to design using ASD. Okay, then solve mo yung overturning moment. Okay, if you solve the overturning moment, then maybe if you're using ASD, so this is a steel, so 0.6 Fy equals to U over Sx or Mn over Sx. Okay, you can solve this Sx. Okay, this Sx is what is the section modulus of this steel reinforced. This is steel. Yung 0.6 Fy is yung FB mo using AST. Okay, so yan, basically ganyan lang yung mag-design for the sheet pile retaining wall. So this is manual calculations for the sheet pile retaining wall. Okay, and last is we have this anchored earth retaining wall. So if you remember, nag-design tayo nito sa example problems. Okay, meron tayong sheet retaining walls, then meron tayong tensions dito for the anchored piles. Okay, if you recall this one, meron tayong soil dito. Okay, this is yung soil or active. This is yung passive soil. Okay. Ayan. So nag-solve na tayo dito sa anchored earth retaining walls. Okay. So this type of retaining wall are fixed at the base and are supported by a row or two rows of ties or struts placed near its top. Okay. This is these struts, okay, will serve as additional tensile capacity to your retaining wall. So this is your retaining wall. These anchored struts or yung struts dun sa within the backfill will give additional strength in tensile force in your retaining wall. So kunwari, medyo mahina yung tensile capacity nung ginamit mong material for retaining wall, maybe you can use this anchored earth retaining wall. So maglalagay ka lang ng parang tensioner or struts dun sa loob ng backfill. Okay? So that is the anchored earth retaining wall. So do you have any questions, Kas? Okay. So if not, start discussing. Tingnan natin kung hanggang saan tayo for the miscellaneous topics in retaining walls. Okay. So this one should be this one. Okay. Okay. So, for now, alam nyo na yung different types of retaining walls. So, I think marami na rin tayo na-design for retaining walls. Na-design tayo ng gravity, gravity retaining walls. Wala pa tayo nitong cantilever retaining walls. Okay, this counterfort. Okay. I think also nakapag-design na rin tayo nitong sheet pile retaining walls. Okay. Nalaman natin yung forces. Actually, analysis pa lang pala. Nalaman natin yung forces that will resist this sheet pile retaining walls and this anchored earth retaining wall. Okay. So this time, we are discussing these brace cuts and cantilever retaining walls. So we will give an overview in analysis of brace cuts and cantilever retaining walls. Okay. So this is a miscellaneous topic especially for PCSE or specialization for for structural engineering, foundation and okay. So this one is brace cuts. Brace cuts are the excavations that are laterally supported. The vertical side of the excavations are supported by a sheeting or a bracing system. So it consists of relatively flexible sheeting placed against the excavation walls. Okay. So for example, limited lang yung material na gagamitin sa site. And you have this, I think, napakalaki ng surcharge mo, for example. Okay, for example, kasi meron sa taas, may mga different equipments ka. Okay, may dadaan dyan na, let's say, dito. So, for example, may backhoe ka na masyadong marami dito sa may taas. Okay, so let's say you have this 100 backhoe, lalagyan mo dito. Then dito sa taas kabila, let's say meron ka namang tawag dito 10 tons ng mga let's say mga material like cement, concrete, steel. Yan yung dito sa taas, or also mga transformers ng building, ng mga building. Okay, so hindi kakayanin ng sheet pile lang. This one, yung sheet piles lang. Ito, hindi kakayanin ng retaining wall. So, as a structural engineer, ano yung gagawin natin para additional support dun sa ating system, sa ating retaining wall? This one is yung brace cuts na tinatawag. Okay, yung brace cuts is basically maglalagay ka lang ng bracing system dun sa cuts. Okay? Again, maglalagay ka ng bracing system dun sa cuts or dun sa excavation. So ito yung mga bracing system. This one, maglalagay ka ng brace. This one, and this one. Okay, this one. Maglalagay ka ng brace dito, dito. This one. Okay. So this is a solution kapag medyo malapit lang yung dalawang sides. Okay, take note, medyo malapit lang sila ha. Pag malayo yan, parang hindi na siya economical. Kasi nga, napakahaba ng gagamitin mong material for the bracing. So, hindi naman siya ganun ka-effective or ka-efficient yung design mo. Okay, so this one is typically mga 12 meters lang yung pagitan. 12 meters. I think 12 meters yung pagitan. Okay? So kasi yung mga 12 meters na yan, pwede yan isang buuan ng steel. May pwede yung ipa-manufacture ng 12 meters na straight. Okay, so that is yung brace cast. So using this spec 1969 earth pressure envelope. Okay. So this is ito kina-consider pa rin siya ngayon kahit 1969 siya na-discover ni Peck, ni Dr. Peck. Okay. So many designers still using this Peck earth pressure envelopes for retaining walls. Okay. So for example, we have these retaining walls. This one. We have this H and B. Okay. So, ang ginagawa dito class is nagko-consider ng nag-a-assume ng pressure diagram. So, parang na-discover ni Peck yung pressure diagram. Okay, wait lang class. Okay. I think, sorry, medyo may ingay. Malakas pa class. Yung noise sa likod.
Naman po, sir.
Wala naman. Sensya na. Okay. Anyway, this one is yung Peck earth pressure envelopes. Okay, so after observation of several brace cuts by Peck in 1969, suggested using apparent pressure envelopes for the following guidelines. So yung gamma is taken as the effective unit weight while the water pressure are added separately. Okay. So this gamma, yan yung mga gamma, yung mga pressure niyan. Meaning, kung meron kang retaining wall, this one, okay, you have a retaining wall with H, okay, with height H. Okay, so this is different class in lateral earth pressure. For the lateral earth pressure, di ba, we're considering different cases, di ba? Sa soil, due to water, due to backfill. Okay, so this time, yung using this Peck earth pressure envelope, okay, considering one soil only, no pressure diagram, okay, no additional pressure diagram due to backfill, due to cohesion, due to water, the poor water pressure. Okay, so this time, ang kino-consider niya lang is yung soil. Okay, this one. So kaya siya meron siyang 0.65 kA gamma H for sands. Ito yung pressure diagram dito. For soft clays, okay, at 0.25 H, we have this linearly increasing load from 0 to load P. And from 0.25 H to 0.75 H, we have this uniformly pressure of P. Okay. Then for stiff clays, we have this trapezoidal shape. Okay. Isosceles trapezoid. Okay. So this one at 0 to 0.25 H, we have this increasing pressure from 0 to P, which is your P is equals to 0.3 gamma H. Okay. Then from 0.25 H to 0.5 H, we have this uniformly distributing stress of pressure P. And from 0.75 H to 1.0 H, we have this linearly decreasing pressure of from P to 0. Okay, this is for stiff clays. Okay, typically yung range ng stiff clays is 0.2 to 0.4 for this one. Okay, however, in other reference, we have this notation. Okay, so for soft clays, this is when your gamma H over C is less than 4. So yung gamma H over C na yan is dito rin siya na-derive. So if you can derive, let's say this one for C gamma H, greater than 1, cross multiply, you have this 4C greater than gamma H. Then, okay, then, divide all by the cohesion value, you have this 4 gamma H over C. Okay, so this gamma H over C less than 4 is for soft clays, and you have this gamma H over C which is greater than 4 for stiff clays. Okay, this one. Okay, so let's try to solve and using this brace sheeting in sand layer. So this is a passport exam on May 2005. Okay. A 7-meter deep brace cut in sand is shown in the figure, this one. So in the plan, the struts are placed at a spacing of 2 meters center to center. Okay, using PEX empirical pressure diagram. Let us compute the strut load at level A, strut load at level C, and strut load at level B. So, ayan. So, we have this sand with phi, which is 30 degrees, angle of internal friction, which is 30 degrees, and the unit weight of 16 kilonewton per cubic meter. Okay. So, for the solution, using this sand PEX empirical pressure diagram. So this is sand. So basically, yung ating diagram is ito lang. Okay. So solving for the strut load at level A. Okay, so for solving for the strut load at level A, so using this pressure diagram by PEX, your pressure is equals to 0.65 gamma H K sub A. Okay, so solving for K sub A, which is 1 minus sine phi over 1 plus sine phi, you have this Ka, which is 0.833. Then your sigma or your pressure stress is 0.65 gamma H times Ka. So yung gamma mo is 16, your H is 7 meters. So 2 plus 2 plus 2, which is 6 plus 1, that is 7 meters. Therefore, your pressure is 9.7 per square meters. Okay. So how are we going to solve for the load at A, load at B, and load at C? Okay, so basically para lang tayo nag theory of structures. Okay, drawing a free body diagram. So please take note, class, that strut loads may be determined by assuming the vertical members are hinged at each strut level except the topmost and the bottommost layer or struts. Okay? So ang ibig sabihin nito, class, they are assuming that we have no rotation or no moment anywhere, any struts between the topmost and bottommost struts. So ito yung topmost struts natin and this is yung bottommost strut natin. So basically ito lang yung ating hinge. Okay, this one we are assuming that there is no rotation and no moment at point B. Okay, meaning we have no moment or no rotation, okay, in point B. Kasi dun sa top and bottom struts, okay, so kapag may active pressure, di ba, nasa taas lagi yung ating pinakamataas na, kasi parang ganito yan eh. Kung ito naging mataas yung load sa kabila, okay, mataas yung load sa kabila, ang mangyayari, ganyan, di ba? Tutulakin ng struts yan. Tutulakin ng struts yan. So, meron kang delta H dito na malaki. May delta. So, let's say delta dito. And this one is, nagkaroon ka ng delta dito sa ilalim. Okay. That is why yung top and bottom struts lang yung mayroong assuming na may rotation or may movement. So yung gitna, for meaning yung parang yung gitna, parang halos wala siyang halos walang parang naka-hinge lang siya, no rotation. So vice versa, kapag nandito naman yung mas malaki yung surcharge load dito, yung pressure dito, yung lateral pressure. So mangyayari, kaya mas malaki yung lateral pressure dito sa kabila, mas malaki yung tulak. Mangyayari is gaganto naman yung sides. Okay? Then mas malaki yung delta dito sa ilalim. Then yung delta dito sa taas. So that is why we have this assumption na yung anywhere between the top and bottom is assumed to be hinge or no moment. So separating the top strut B to solve for load at level A. So considering natin, cut natin dito yung hinge. Cut tayo dito sa hinge. Okay, so di ba pwede tayo mag-cut sa hinge kasi nga no rotation naman siya, no moment. So if you recall the theory of structures, so pwede tayo mag-cut dito kapag no moment. Okay, meaning wala tayong internal moment na i-consider. So considering at top, we have this RA and RB1. This should be RB1. Okay. So, kasi kapag nagputol ka dyan, meron kang hinge dyan. So, ang mangyayari is meron kang ganito. Meron kang strut dito. Let's say this is your RA and this is your RB1. Kaya ko siya sinabing RB1 is this is your first contribution of your reaction at B. Okay, yung dito naman sa ilalim, considering sa ilalim, separating yung ilalim, okay, you have this RB2 and you have this RC. Then yung point B dito is the summation of your RB1 plus RB2. Okay? So that is this free body diagram of your brace cuts. Okay? Okay, anyway, so let's separate the top of the strut B to solve for the load at level A. Okay, so we have this pressure diagram of 24.27. You have this. Okay, we have this RA assumption. Let's say going to the right. And yung RB1. So this is the point B is assumed hinge. Therefore, we can sum moment at B equals to 0. Okay. So 2 times RA, the 2 meters distance times RA is equals to 24.27 times 3. The total length nito is 3 meters. Okay. Then times 3 times 2 meters. Okay. This 2 meters class is using a spacing of 2 meters. Okay, meaning, yung dun sa going out of your screen, meron siyang spacing ng strut na 2 meters. Okay, so kaya tayo nag-consider ng 2 meters dito. So, pwede rin naman considering 1 meter na spacing. Oh, it's up to you guys. Pero, bakit kasi 2 meters kung ang spacing natin is yun yung kinonsider nating spacing. Okay, meaning, ito yung 2 meters, ito yung 2 meters. So, ito yung ating retaining walls. Okay. Okay, then, using the tributary area, so this is this one, and this one. Okay, so this is 1 meter, and this is 1 meter. So, that is 2 meters. Okay, so that is why you have these 2 meters. And the centroidal distance to RB is 3 halves. Okay, so that is your RA to be 109.22 kilonewton. Okay, then solving for the strut load at C, again, take note that the strut loads is assumed to be hinged at the middle portion. Okay, so strut load at C, considering naman natin yung bottom of the strut B, to solve for the load level at C. Okay, kung mapapansin nyo, they have this RB2. So let us solve muna yung RB1, yung dito kanina. RB1, this one. So summation forces horizontal, your RA is equals to RB1. Therefore, that is also equals to 24.27 times 3 times 3 meters times 2. Since 2 yung center to center spacing. So RB1 is equals to 24.27 times 6 minus 109.22. Therefore, your RB1 is 36.4. Okay. Now, considering this bottom of strat B, okay, so summation moment at B equals to 0. Therefore, your 2 RC, okay, 2 times RC is equals to 24.27 times 2 for the center to center spacing times 4, that is the total length, and the centroidal distance 2. So ito yung centroidal distance. Dito yung nag-act yung center natin to RB, which is 2. Okay? So that is why you have this RC to be 194.16 kilonewtons. Okay? Then solving for the strat load at B. So solving for the strat load at B, now we can solve for RB2. So considering this lower portion of the free body diagram. So RB2 plus RC is equals to 24.27 times 4 meter length times 2 center to center spacing. You have this RB2 equals to 0. So therefore, the total reaction at B is the summation of your RB1 and RB2, which is 36.4 plus 0, which is 36.4 kilonewton. Reaction at B, or the strat load at B. Okay, therefore, i-design mo yung ating, design mo yung iyong struts with compression load. Okay, that is a compression load. I-design mo yung strut with the compression load and tension load of RA, RB, and RC. Okay, so I think alam niyo naman kung paano mag-solve ng paano mag-design for a material with a given compression or tensile load. Okay, so checking if we have the correct values. RA plus RB plus RC is equals to 24.27 times 7 times 2 meter spacing. We have this 339.78 and 339.78 kilonewton, which is okay. Okay, so next meeting na lang natin i-discuss yung brace sheeting for clay layer. Okay, sige. So do you have any questions, class, before we end this meeting? Okay, sige. So basically, ganito lang siya. Ito lang yung ating pressure diagram. Yeah, for sand, soft, and stiff clays. Okay. So I think mas maganda if mag-advanced reading tayo. Okay, sige. So